Welcome to Brain Vision.
In this problem, we have two disks of different masses which are moving toward each other with different velocities. They strike each other with a given coefficient of restitution, and we wish to calculate the final velocities of either disk. Now, the first thing we will do is use the conservation of linear momentum. So the conservation of momentum tells us that the initial mass of disk A times its initial velocity, so MAVA1, plus the initial momentum of disk B, MBVB1, is equal to the final velocity at which disk A moves off, MAVA2, plus the final momentum of disk B, which is MBVB2. So if we take the right direction, as we see in our diagram, we take the right direction as positive, we get that the mass of A, which is 2, times its velocity 5 meters per second, plus the mass of B, which is 4, times its velocity initially minus 2 meters per second, is equal to 2 times the final velocity of A VA plus 4 times the final velocity of B VB2. So we have an equation here with two unknowns. We'll call this equation 1. It's relating VA and VB. Now, if we look at the coefficient of restitution, we know that the coefficient of restitution, E, is equal to the final velocity of B, VB2, minus the final velocity of A, VA2, all over the initial velocity of A, VA1, minus the initial velocity of B, VB1. And again, we'll take the right direction as positive, and we get this coefficient of restitution, which is given as 0.4, must equal VB2 minus VA2 over the initial velocities 5 minus 2. And so we have another expression, equation 2. So we have two equations with two unknowns. So we can solve the system equations 1 and 2 simultaneously. And if we do so, we get that the final velocity of disk A, VA2, is equal to minus 1.53 meters per second. So disk A moves off with a speed of 1.53 meters per second to the left. And disk B has velocity 1.27 meters per second, and this is to the right.